girl, so she's using her phone.
Okay. Good afternoon, everyone. Thanks for joining the live session today. Today we'll have a session where we're going to look at some questions together. We have topics from third graders all the way up to pre-calculus. Looking forward to spending the time with you, the hour with you. And I'm also looking forward to learning from you, and hopefully we can have a good time. Today's session is going to be what we're going to try to do from here on out. We're going to have some questions that are academic, and then towards the end we're going to have some trivia, some quizzes that should help you out in just having a good time. So I'm going to wait for probably a few more minutes, maybe a minute or two, just so we can have more people in the session, and then we can get started. Thanks for joining us once again. Looking forward to the hour. It should be entertaining. I have a lot of word problems today because I want students to start getting familiar with how to deal with word problems. This is one thing I know for sure in my years of tutoring some students all the way from elementary to even college level. Word problems tend to be a challenge for a lot of students. So I'm trying to make today mostly word problems. Let's see how that goes. Okay. Let's go ahead and get started. So our first problem is a word problem for 3rd to 5th graders. There are a few things that this question is testing. One of them is testing if you understand polygons, and also understanding if it's testing your understanding of perimeter. So the sides of a polygon below are of equal length, and the perimeter is 63. What is the length of each side? What is the length of each side? For those who are just joining, welcome to our session. We're going to have questions out here, and then I'm going to give you a chance to solve it. And then if I don't get a response in a decent amount of time, probably within a minute or so, then I'll go ahead and show you how to do it. Otherwise, if I start getting responses, I'll give you about 2 minutes to get through the question, and then we will move on to the next question after solving it. Okay, let's go ahead. I'm not getting any responses now, so let's go ahead and look at it together. If the sides of the polygon below are of equal length and its perimeter is 63, what is the length of each side? So what you want to do is find out how many sides the polygon has. So let's count. We have 1 here, 2, 3, 4, 5, 6, 7. So the polygon has 7 sides. So this is what we will call a heptagon. A heptagon. And we want to find out the perimeter of the heptagon. So all the 7 sides have the same value. So the perimeter is going to be adding all of these 7 sides together. And now we want to find out if the perimeter is 63, what is the length of each of the sides? If all the sides are equal, the length of each of the sides is going to be 63 divided by the number of sides. So this is going to give us 63 divided by 7 is going to give us 9. So the way you can check this actually is to add 9 to itself 7 times. 9, 9, 9 plus 9 plus 9. This is the same as 9 multiplied by 7. This is going to give you 63. So we can verify that our answer is correct. Now let's look at the next question. So this is most likely 3rd graders can do this, but I would say probably about 4th and 5th graders will be very comfortable doing this. So if 5 over 7 is equal to x over 56, what is the value of x? Here we're looking for equivalent fractions. So we're trying to form equivalent fractions. And so I'll give you about a minute to see if anyone can solve this. Otherwise, we'll go ahead and solve it together. Any third or 5th graders in the session right now? 3rd, 4th, or 5th graders? Okay, I don't see any responses, so let's go ahead. So we have 5 over 7 is equal to x over 56. So what we're trying to ask ourselves is, what is another way of writing 5 over 7 so that you have a denominator of 56? The simple question to ask yourself is, what number would you multiply by 7 to get to 56? Now, if you know your multiplication table, you'll find out that 7 multiplied by 8 is going to give you 56. So we're multiplying 7 by 8 to get 56. And whatever you do in the denominator, you have to do in the numerator as well. So you multiply 5 by 8 as well. This is going to give you 46. over 56. Now let's compare what we have, 40 over 56. We compare it to x over 56, and we can see the denominators are the same, so that means the numerators are the same. So x is equal to 40. So that's how you solve this problem. Next problem, 6th graders, we're looking at a cylinder whose radius is 6 feet and has a volume of 540 pi cubic feet. What is the height of the cylinder? What is the height of this cylinder? Feel free to ask any questions as we go along. This session is for you. I want to make sure that you can get the best out of it. So if you have any questions as we're walking through these problems, please ask along and I'll be glad to assist you with the questions. If you ask any questions that are related to the questions that we're solving, that's fine. If you also ask questions that are different, I'll go ahead and try to address them as soon as the question I'm walking through is completed. So the cylinder has a radius of 6 feet and has a volume of 540 pi cubic feet. How would we go about this? The volume of a cylinder, well, let's just start with the volume, is always area of the base. When you're dealing with three-dimensional figures, area of the base multiplied by the height. Okay, and we know that the cylinder has a circular base, so it's going to be the area of a circle at the base, which is going to be pi r squared, then multiplied by the height. So now we have some information here. We have volume is equal to 540 pi cubic feet. We have the height is equal to 6 feet. So now we'll go ahead and substitute these values into the volume. So we have volume. Well, let's go ahead and just use the volume since we're going to be substituting the values. So the volume here is 540 pi equal to pi, your radius is 6 squared, and then we multiply by h, which is the height. Now we're trying to find out the value of the height. So let's simplify this. 540 pi is equal to 36 pi multiplied by the height. Now to get the height, we're going to divide, because to get the height, we're going to find out how we isolate h, which is the variable. So the coefficient of h is the number to the left, is the term to the left of h, which is right here. So we're going to divide both sides by 36 pi, 36 pi. So now we have, these entities are going to cross each other out. The pi is going to cross out the pi, and now we are left with 540 divided by 36. We can divide this out. How many groups of 36 and 54? I have 1. 1 multiplied by 36 is 36. Now we can subtract. We have 8, 1, and then we bring down the 0. 180 divided by 36 is going to give you 5. 5 multiplied by 36 is going to give you 180 as well. 180, and when you subtract you have 0. So therefore h is equal to 15 feet. Next question. So we have a symbol before x, and anytime the symbol is before x, we have 3x squared plus 6x minus 11. What is the value of a symbol before 2? So if you're 6th or 7th grade, this should be Okay, we'll do one on dividing fractions. After this, we'll pick a question on dividing fractions. So, what is the value of this symbol with a 2? I like this question because it's asked actually in higher grades. If you're taking the SAT, ACT, or even sometimes in the GRE, you like college level test, they actually ask this, but you get the foundation built in the 6th grade. So let's go ahead and solve this. Is there any 6th grader or 7th grader that wants to attempt this? Let's go ahead and try it out. Let's give a minute. After this, we'll go ahead and work on some fraction, and then we'll come back to the other questions that we have for the day. Towards the end, I have some puzzles for you all. Let's see how you do with these puzzles today. Okay, I'm not getting any responses. So here's what this means. It means that anytime I have this square, this blue square before x, I'm going to multiply 3 by x squared. I'm going to add that to the product of 6 and x and subtract 11 from the result. So let's call this, ignore the color. So this is 2 is going to be equal to 3 multiplied by 2 squared minus 6 multiplied by 2 minus 11. So this is going to give us 3 multiplied by 4 minus 6 multiplied by 2 is 12 minus 11. So this is going to give us 12 minus 12 minus 11. This is 0 minus 11, which is going to give us negative 11. So if you notice, when I'm doing math, I like to follow a pattern, a sequence. If you do this, the reason why I like to do this, and I encourage every student that I have to do this, is that you want to if someone is trying to help you figure out where you're going wrong, they can easily pinpoint where you've gone wrong. If you look at this right now, you can see that if I make a computation error, you can see exactly where that error came about. And so this is one of the methods I recommend that you develop, because it's just easy for you to work with. It's easy for your teachers, it's easy for you to understand. And if you're preparing for your test, you may be able to actually understand why you did what you did when you're doing your review. All right. Another question for 6th to 8th graders. The sum of 3 consecutive odd numbers is 99. What is the value of the largest number? 6th to 8th graders. Actually, I did promise that I was going to do something else. Let's go ahead and do some fractions before we do this. Okay, so the question was, can you do a problem about dividing fractions? Let's go ahead and look at division of fractions. So, dividing fractions. Dividing fractions. So, let's go ahead and try something like 3 over 4 divided by 1 over 2. And then I'm going to do one improper here, which is 7 over 4 divided by 12 over 5. Okay, so there's a simple rule with fractions. The first thing you want to do actually is to always convert your your mixed fraction to improper fraction. But if you have proper fractions, here's what you want to do. You leave the fraction on the left hand side of the division symbol, you leave it alone, and then you change that division symbol to a multiplication symbol, and then you change the position of the numerator and denominator of the fraction to the right of the division sign, 2 over 1. So now you can either multiply across, or you can do your division. So let's go ahead. 3 multiplied by 2, 6. 4 multiplied by 1 is 4. You divide again, you divide by 2 because they are both even numbers. 6 divided by 2, we have 3. 4 divided by 2, we have 2. So this is the same as 1 and a half. And the way we get that is this: 3 divided by 2. There's only one group of 2 in 3. 1 multiplied by 2, we have 2. We subtract, and we're left with the remainder of 1. So this is your quotient, which is the number right here. And then this number is the one right here. And 2 is your denominator. Okay, let's try one with improper fractions. So the rule stays the same. So you leave the fraction on the left of the division symbol alone. So 7/4, you just write it. Now you're going to change this to a multiplication, and then you're going to switch the position of the fraction on the right hand side of the division symbol. So this is going to give you 5/12. So this is going to be 7 multiplied by 5, we have 35. 4 multiplied by 12, we have 48. Let's try another one here. What if I had to divide a fraction by a whole number? So let's say dividing a fraction by a whole number. Let's go ahead and try something like 2/1/3 divided by 4. Let's try that. So the first thing you want to do is write both of them so that they are in this form, a/b. So I don't want any whole numbers. I want them to either be, both of this to be written as improper fractions. So for this one, for the one on the left, 2/1/3, 2 multiplied by 3, 6 plus 1, we have 7/3. Then we divide by, so here we have 4. 4 is the same as 4/1. And now the next thing we're going to do is now that we have our fractions laid out as improper fractions, what we're going to do now is use our rule, which is to leave the fraction on the left side alone, change the division to a multiplication sign, and then we're going to switch the position of the numerator and denominator of the fraction on the right. So we change that to 1/4. So this is going to give us 7 multiplied by 1, we have 7. 3 multiplied by 4, we have 12. One more example that is a little bit different. What if I wanted to divide a whole number by a fraction? So let's say 8 divided by 4/2. Okay? First thing you're going to do is to convert both of them to improper fractions. So this is going to be 8/1 divided by 4 multiplied by 3, 12, plus 2, we have 14. So that's 14/3. So the next step we're going to use is the rule where we leave the fraction to the left of the division symbol alone. We change the division symbol to a multiplication, and then we switch the position of the numerator and denominator on the fraction on the right to the right of the division symbol, which is 3/14. So 8 multiplied by 3, we have 24 divided by 14. Now we have two even numbers, so we can divide both of them by 2. So 24 divided by 2, we have 12. 14 divided by 2, we have 7. So 12 divided by 7. How many groups of 7 in 12? There should be one of them. 1 multiplied by 7, we have 7. Subtract 12 minus 7, we have 5. So 12/7 is the same as one whole number here, then the remainder is 5, and we're dividing by 7. So I hope this helps with division of fractions. There are a lot of other questions we could have done, but I think this should give you a good head start with dividing fractions. If you have any more questions about this, please feel free to ask. I don't mind going over it again. Okay, so now let's get back to the question we're about to work on before we had to deal with some division of fractions. So the sum of 3 consecutive odd numbers is 99. What is the value of the largest number? So here it requires you to understand what it means to have consecutive odd numbers. Let me give you an example of consecutive odd numbers. You have 3, 5, 7, 1, 3, 5. So these are consecutive odd numbers. So this should give you an idea of what you will need to get the answer. All right. Anyone trying this out? Any answers yet? So the sum of 3 consecutive odd numbers is 99. What is the value of the largest number? Wonderful, wonderful. I got an answer already. So let's see if we get one more answer and then we'll go ahead and walk through this together. Let's try one more answer. Okay, I'm not getting any other answers. So here's how we're going to go about this. We will start by figuring out, let's say that the first number, let's say the first odd number is equal to x. Okay, so our first odd number is going to be x. What is the second odd number going to be? Pay attention to this pattern here. We're always increasing by 2. So the next one is going to be x plus 2. What about the third one? We're increasing by 2 as well, or you're increasing by 4 from the first one. So this is going to be x plus 2, which is the previous odd number, plus 2. So we have x plus 2, and then x plus 4. Now we're told that the sum of all these numbers is 99. So we have x plus 2 plus x plus 4 equal to 99. So let's go ahead and add. We group common terms together. So we have x plus x plus x plus 2 plus 4 equal to 99. So x plus x plus x is 3x. Then 2 plus 4 is plus 6 equal to 99. And then we're going to isolate x. So first we want to subtract 6 and subtract 6. So you have 3x is equal to 93. You divide both sides by 3. Divide both sides by 3. So x is equal to 31. But pay attention to the question. It says the largest number. Okay? So we know here that our largest number is x plus 4. So the largest number is equal to 31 plus 4, which is equal to 35. Pay attention to the question. But good try though, good try, good try. Let's go ahead and do this one. The volume of a square prism below is 150x. What is the value of x? So the volume of the square prism below is 150x. What is the value of x? So some knowledge you need here is going to come from 6th grade, but the bulk of the knowledge you need is going to be in Algebra 1. Okay, any answers? Do we have anyone in Algebra 1, Algebra 2, or pre-calculus here? Okay, let's give it a try. We have the volume of a prism. The volume of a prism. Especially we have, I call this a square prism. Actually, it's a rectangular prism. Okay, we call this a square prism, and the reason why it's a square prism is because this is being treated as the base. This face right here is treated as the base, and you can see also here you have a square as well. That's why it's called a square prism. So we have the volume of a square prism is length multiplied by width multiplied by height, which is the same as the area of the base, and we have a square in the base multiplied by the height. So now let's go ahead and figure out what this is. So 150x, which is the volume. What is the area of the base? X multiplied by x, x multiplied by x, and then the height is x plus 5. So now we have 150x equal to x squared multiplied by x plus 5. So 150x equal to x cubed plus 5x. And now we're going to bring all the terms together on one side of the equation. And that is going to give us x cubed plus, this is going to be 5x squared, sorry, plus 5x squared minus 150x equal to 0. So now we can solve for x. Let's go ahead and I factor out x first. So we factor out x is going to give us x squared plus 5x minus 150 equal to 0. So we're going to solve for, we're going to first factor the term in the parentheses. So let's go ahead and factor that. So we need to find out two factors of 150, of negative 150, that will give you a sum of 5. So let's go ahead. 150, no, that's not going to work. 2, 75, not going to work. 3 and 50, not going to work. 5 and 30, no. 6 and 25, I can't create 5 from this. And then we have 10 and 15. So we can see a relationship here. We can see a relationship here that would lead us to 5. So this is going to give us x. So we're going to have a positive on 15 and a negative on 10 because we want a positive 5. So we're going to have x plus 15 multiplied by x minus 10 equal to 0. So this is what we're going to find the root of this. So we have some options here. X equal to 0. Another option is x plus 15 equal to 0. And then the final option is x minus 10 equal to 0. So now, what are we going to do? X equal to 0, we already have a value for that. X plus 15 equal to 0. Let's go ahead and subtract 15 from both sides. So x equal to negative 15. And then x minus 10 equal to 0. Let's go ahead and add 10 to both sides. X equal to 10. Now the question is, which of this is going to be the answer? So we have several values. X equal to negative 15, 0, and 10. Which of these would you have as your right answer? The answer here is pretty technical, and I want you to just take note of this. Whenever you're dealing with length, length cannot be 0 and it cannot be negative. Length cannot be 0 and it cannot be negative, so you're going to choose the only positive value. So therefore, x here is equal to, x is equal to 10. So that's your answer for this question. Let's try a few more questions, and then we'll go to our quizzes. So I'm seeing here, what is 31 multiplied by 89? Do you want me to show how to do that, or? Okay, let's see, 31 divided by 89. Let's go, 31 multiplied by 89. Let's go ahead and do that. And then we'll get to, can you shed some more light on what you mean by dividing unit fractions by whole numbers visually? Just shed some more light. I think I have some ideas. I just want to be sure that what I'm doing will meet your need. So 31 multiplied by 89. So I'm going to try the matrix method, and I'm going to try the algorithm method for 31 multiplied by 89. So this is 31 multiplied by 89. Let's go ahead. If you're using, I think this is very Common Core-like. If you're in a school program, or your children are in a school program that uses the Common Core, this is going to be very familiar with them, or familiar to them. So 31 is the same as 30 plus 1. 89 is the same as 80 plus 9. So we're going to have 31 here, 89. So we're going to multiply and create our matrix. 30 multiplied by 80, so that's going to give us 24 and 2 zeros, because you pay attention to the non-zero numbers. So 3 multiplied by 8, 24, and you add the 2 zeros to the end. Then 80 multiplied by 1, that's going to give you 80. 30 multiplied by 9, let's pay attention to 3 multiplied by 9, which is 27, attach a 0 to the end, and then 9 multiplied by 1, that gives you 9. So now you're going to add all these numbers together, so that's going to give you 2400 plus 270 plus 80 plus 9. So now we're going to fill up every space with zeros, just so that we have the same number of digits we're working with. And so zeros plus 9, you have 9. 7 plus 8, you have 15. So we're going to write 5 and bring 1 up here. 1 multiplied by 1 plus 4 is 5, plus 2, we have 7, and then 2 plus a bunch of zeros is 2. So that is the answer. So this is called the matrix method. This is the matrix method. Now let's use the algorithm method, which is just following a sequence of events here. So we're going to have 31 multiplied by 89. So we start in the ones position. So when we start in the ones position, our responses will start from the ones position. 1 multiplied by 9, we have 9. 3 multiplied by 9, we have 27. Okay, so the next thing we're going to do is we switch over to the tens position. When you have a number in the tens position, it means that you can safely put a 0 in the ones position here. And so you have 1 multiplied by 8, you have 8. 3 multiplied by 8, you have 24. And then you can put a 0 here, so you have the same number of digits. And now let's go ahead and add. 9 plus 0, we have 9. 7 plus 8, we have 15. So we write 5 here, and we bring 1 up here. 1 plus 2, 3 plus 4, 7. 0 plus 2, we have 2. So these are the two different ways of solving questions when you're trying to multiply two-digit numbers. You can actually apply this method for as many number of digits as possible, but as you get further in your grades, most likely your teachers will prefer you use the algorithm method, because this matrix method can take quite a while to do. Okay, we have about 20 minutes to go, so I'm going to try a few more problems here, and then we'll do some quizzes, or I call them some puzzles. So what is the equation of a line perpendicular to 3x minus y equal to 7 and passes through the point -1, -2? the equation of a line perpendicular. The first thing you always want to do when you have this type of problems, does anyone want to try this? I'll give you a hint. Always write your equations in this form, y equal to mx plus b. That's the first thing you always want to do when you're dealing with a linear equation, y equal to mx plus b. Okay, let's go ahead and try this out. So the equation that we have, the equation of the line is 3x minus y equal to 7. So we're going to write it in the form y equal to mx plus b. So I'm just going to add y to both sides. So 3x equal to 7 plus y, then subtract 7. So you have 3y. Actually, should be x here. So we have 3x minus 7 equal to y. So our equation is y equal to 3x minus 7. Now, when you have an equation in this form, 3 is going to be your slope. Now, the important thing that you need to pay attention to here is perpendicular. And when you have two lines that are perpendicular, their slopes are the negative inverses of each other. So for the new line, let's just put right here, new line, the slope is going to be, let's put this, and then I'm just going to write slope. New line, slope is going to be equal to -1/3. Okay, now we have a point that it passes through. This is a comma right here. We have a point that it passes through. We're going to use this formula, y minus y1 equal to slope, which is m, x minus x1. So we're going to now have y minus y1 is going to be -2, y minus -2 equal to slope is -1/3, x minus x1 minus -1. So this is y plus 2 is equal to -1/3 x plus 1. So now we have y plus 2 equal to -1/3 x minus 1/3. So now we want to write it in this form here. So we're going to subtract 2 from both sides. Subtract 2. So therefore, y equal to -1/3 x minus 2 minus 1/3. When you have the same sign on the numbers, you're going to add them together. So that's going to give me 2 1/3, and then we keep the sign. So we can write it in this form, or we can write it in this form, -1/3 x minus 7/3. So this is the equation of the line that is perpendicular to this line. Okay, let's do a few more. This is for Algebra 2 students, and some pre-calculus students should be able to do this one. So this is Rationalizing Radicals. Rationalizing Radicals. As a rule, we don't like to have irrational numbers in our denominator. We should not be having irrational numbers in our denominator. So whenever you have an irrational number in your denominator, generally we want to do something about that. So let me just go ahead and show you this so we can get to our quizzes, our puzzles. So when you have 2 minus the square root of 3 divided by 3 plus the square root of 2. Now what we're trying to do is we need to find a number that, or an expression that we can multiply the denominator by to eliminate the radical. And here's one thing you want to remember. A plus b multiplied by a minus b is going to be a squared minus b squared. So that's the rule we're going to use here. So we're going to multiply both of them by the conjugate of this denominator, which is going to be 3 minus square root of 2. And because we do that, we also multiply the numerator by 3 minus the square root of 2. So now, why do we do this? Because if you look at this on its own, let's look at this conjugate on its own right here. If you actually divide this out, what do you get? You get 1. So you're actually multiplying, it's the same as multiplying this by 1. And remember, when you multiply an expression, a number, or a term by 1, it maintains its value. That's the reason why we do this. So now let's go ahead and multiply the numerator and the denominator. So we have 2 minus square root of 3 multiplied by 3 minus the square root of 2 divided by 3 plus the square root of 2 multiplied by 3 minus the square root of 2. So now let's pay some close attention to what's happening here. We're going to FOIL the numerator and the denominator. So this is the first terms, 2 multiplied by 3. Then let's look at the outer terms, which is 2 multiplied by minus square root of 2. So it's going to give us negative 2 square root of 2. The inner terms right here, negative 3 square root of 3. And then our last terms, this is going to be positive because the sign here is negative and the sign here is negative. Negative square root of 3 multiplied by square root of 2. So there's a multiplication here. Now we divide. So look at this. Let's compare the denominator against this term here. You have a plus b, a minus b is going to give me a squared, 3 squared minus b squared, square root of 2 squared. So now let's go ahead and simplify the numerator. 2 multiplied by 3, we have 6 minus 2 square root of 2 minus 3 square root of 3, because you don't have any common terms, plus the square root of 3 multiplied by the square root of 2 is going to give you square root of 6. And then you divide by 3 squared is going to be 9. Square root of 2 squared is going to give you the square root of 4. So this is going to give us 6 minus 2 square root of 2 minus 3 square root of 3 plus 6 divided by 9 minus 2, which is going to give you 6 minus 2 square root of 2 minus 3 square root of 3 plus 6 divided by 7. So this term and the original term are exactly the same value. If you want, you can go ahead and plug this in the calculator and put also the result here in the calculator. You'll get the same result. This is actually square root of 6. Sorry about that, square root of 6. So here's the reason why I like to show all my steps, because I can actually see where things went wrong. So this is now correct. Let's try one more question here, and then we'll go over to our puzzles for the day. This is pre-calculus, and for students who are in the pre-AP track for their math, if you're in Algebra 2, I think in some states you have the pre-AP Algebra 2. You may actually see this type of problems there. So we're looking for the horizontal asymptotes and the vertical asymptotes of this rational fraction. Horizontal asymptotes, vertical asymptotes of the rational fraction. Let's see what a vertical asymptote is. Vertical asymptote. Some people will call that VA. That's actually very commonly used, VA. So all you're going to do for vertical asymptote is to find the roots of the denominator. So x squared minus 9, x squared minus 9 is going to be x plus 3, x minus 3. So when you look at the vertical asymptote, you're looking for, okay, I'll look at some third grade stuff. We did that at the beginning. We did a lot of third grade stuff at the beginning, but I'll see if we can fit one in towards the end. Or if there are any specific topics that you want me to address, let me know and then we can prepare that for tomorrow's session. So x squared, so what we're looking for is the value of x that if you have that value in the denominator, you have an undefined function. You have something that looks like this, a over 0. This you cannot really do. So the value of x that makes the denominator 0 is what we will call our vertical asymptote. So now so x plus 3, x minus 3 equal to 0. So we're going to find x plus 3 equal to 0. So x equal to negative 3, x minus 3 equal to 0, and then x equal to positive 3. So therefore, our vertical asymptotes here are going to be x equal to negative 3 and positive 3. Now our horizontal asymptotes, there's a rule for that, but in this case, you have the same degree on your quadratic term here. So you have 3x squared, and then you have x squared in the denominator. So you just divide, this is 3. So let's look at this. Your vertical asymptote here, your vertical asymptote is x equal to negative 3 or positive 3, and then the horizontal asymptote is y equal to 3. So now let's go ahead, and this is most likely for Algebra 2 pre-calculus students. So if we don't have any here, this may not make a lot of sense to you. I try to make sure I have enough to cover all the different grades in the session. But if you send me questions about what you want me to focus on, it can actually help me better tailor the session to the specific need that you have. So let's go ahead and look at some puzzles. Oh, you're welcome. No problem. I'm glad to do this. I'm happy to do this. I enjoy doing it too. Okay, what is the missing number? Any answers? I found this puzzle and I found it really interesting. It requires just a little bit of thinking. Any ideas? Well, no answers yet. All right, let's go ahead. And anyone want to try it? Anyone have an answer yet? 34? Huh. Close, but not yet, not there. So let's go ahead and try this. The trick here actually is that you multiply this by 5 and add this together. So 27 multiplied by 5, that's going to give us 135. 59 plus 76, that's going to give us 135. Let's try the same here as well. 20 multiplied by 5, we have 100. 62 plus 38, we have 100. So let's go ahead and apply that here. 14 multiplied by 5, we have 14 multiplied by 5, we have 0, 7. So 70. So 70 minus 24, we have, take one from here, 6. This is 10. 10 minus 4, 6. 6 minus 2, 4. So our missing number here is 46. All right, next one. This actually will most likely be students in, I think 4th grade should be good. Any ideas? Let's see. Anyone come up with an answer? $11? No. Let's see. Good try though. Good try. Any other answers? So we have 5 minutes and we have one more puzzle to go through. Okay. So let's go ahead. I'm going to show you this. So 1 multiplied by itself is equal to 1. 3 multiplied by itself is 9. 5 multiplied by itself is 25. And then 7 multiplied by itself is 49. That's all there is to that one. And then final one. Any ideas? Let me give you a hint. So there's a relationship there. That's your relationship. That should help you get to your answer. Want to try one more time? Okay. So this is multiplied by 4, multiplied by 4, multiplied by 4. This is divide by 3, divide by 3. And so your next number is going to be divide by 3. There you go. There you go. Good try. So that's what we have for today. I know we have 3 minutes to go. Are there any topics that you want me to prepare for tomorrow? I actually like today because we actually got a chance to get into a topic that I didn't have in my list, so which is dividing fractions. So are there any questions or any topics that you would like me to prepare for tomorrow, so that it could be, I want you to get the most value out of this hour that you spend with me. So please let me know if there are. You can always send the question, as a response to this video once it gets posted. And also you can send it now. or just go on our YouTube page and leave a comment. That's fine too. I'll be glad to help you out. So if we don't have anything, I thank you for your hour. Time is precious, so thank you for spending the hour with me, and I look forward to spending more time with you tomorrow. Hopefully, we're able to get past this coronavirus thing that is plaguing the world in a very short time, and that a lot of predictions are false and about how bad it would be. But while we're here, I want to make sure that we can spend our time together working through math and all of that stuff. And I've really been enjoying my time. I look forward to spending an hour with you again tomorrow. And stay blessed, stay safe. Make sure you wash your hands as often as possible. Try to stay indoors as much as you can. Don't go to places where there are too many people, because you don't really know whether they're taking the same kind of safety measures you're taking. So spend time with the family. This can be a blessing for those of us who can see the blessing in it, spending time with our family. And please also remember those that are struggling. Pray for them. Ask God to help them, and ask God to put an end to this quickly. Thank you, and stay blessed. See you tomorrow.